Kinetic friction is 0.4. Force of 2.5 Newton is applied on the block. So you are asked to calculate the frictional force between the block and the floor. তাহলে এই সিচুয়েশনে এফ হচ্ছে 2.5. সো ফার্স্ট বের করতে হবে নরমালটা কত হবে 20 নিউটন হবে। সো করেসপন্ডিং লিমিটিং ফ্রিকশন কত লিখবো মিউ ইনটু এন 0.4 ইনটু 20 means 8 নিউটন। ওকে 8 নিউটন ইজ লিমিটিং ফোর্স। এবার 2.5 দিয়েছে as capital F is less than Fm, the block will not move. The block will not move. এখন কি হবে ফ্রিকশন will prevent the movement. তাহলে এখন এই দিকে ফ্রিকশন থাকবে and that friction is how much? Not the limiting one. তো ফ্রিকশন ভ্যালু কত হবে 2.5 নিউটনই হয়ে গেল। বুঝা গেছে? তো তুমি নরমাল বের করবো, তারপর লিমিটিং বের করবো, দেন চেক whether the capital F is greater than or less than Fm. আমরা পেলাম কি if capital F is less than Fm, that means the particle will not move or the block will not move. যখন মুভিং হচ্ছে না, that means no friction is acting, not the limiting one. এবার রিকোয়ারমেন্ট অফ ফ্রিকশন কত F, এই Fটা হচ্ছে রিকোয়ারমেন্ট অফ ফ্রিকশন কত দরকার 2.5 দরকার। why? Because I am pulling the block with a 2.5 Newton force. তাহলে F যদি 2.5 দরকার হয়ে থাকে, can I give that? Yes, because F number must be less or equals to Fm হতে হবে। নরমাল কত? Normal is 40 Newton. Limiting value কত? Limiting friction is 40 into 0.8. 0.8 means 31 Newton. So in order to start the movement, applied force must be more than Fm. So আমি দেখতে পাচ্ছি F নাম্বারটা less than Fm হয়ে যায়, so block will not move. না ভালো করে পড়া করে কি জিজ্ঞেস করেছে, ঠিক আছে? সো ইন দ্যাট সিচুয়েশন ফ্রিকশন ইজ অ্যাক্টিং হাউ মাচ? এইখানে এখন ফ্রিকশন কত হবে? এইখানে ফ্রিকশন থাকবে 30 থাকবে, ঠিক আছে 30 নিউটন হয়েছে। বাট ইউ আর আস্কড টু ক্যালকুলেট দ্য রেজাল্টেন্ট ফোর্স এক্সার্টেড বাই দ্য গ্রাউন্ড অন দ্য ব্লক। এই ব্লকটার উপরে একটা নর্মাল দিচ্ছে, গ্রাউন্ড দিচ্ছে, হুইচ ইজ ইকুয়ালস টু 40 নিউটন, and same ground is offering a friction of how much? 30 Newton. The resultant of F and N, R number is nothing but under root of F square plus N square. The net force offered by the floor on the block itself, 50 Newton. এখানে জিজ্ঞেস করেছে তোকে how much is the resultant force acting on the block by the ground. So ground is offering both normal as well as দুটোই offer করছে। So there is a rough vertical board, acceleration is A, so that the block is not falling, doesn't fall. So you are asked to calculate the friction coefficient between the block and the board. Let the friction coefficient be mean. The downward force acting on the block is mg, and this mg is trying to pull the block downward. So in order to prevent that, there must be one friction force in the upward. Okay. So since the block is moving in the horizontal direction, so on the block, pseudo will be there. So pseudo will be in this direction, m into a. Okay, it is a pseudo force দেখালাম। The pseudo force is acting opposite to the frame acceleration, magnitude product of mass into acceleration force, and in this direction normal will be there. So normal becomes m into a. What is Fm? Fm is basically mu into n. So mu into ma is the friction force limiting force. So what is the requirement of friction? Requirement of friction is F. That should be equals to mg, and in order to achieve that, that number should be less than Fm. So mg number should be less or equals to mu times ma. That means mu should be greater than or equals to g by a. Okay, mu should be greater than g by a. Again, multiple options correct. So either greater than g by a or equals to g by a. So both A and C. Answer is A and C. এইখানে বলেছে কি, so there is a block placed on a vertical board and the entire board is moving with an acceleration A. Okay, so you are asked to calculate the what is the coefficient of friction. For that, there will be no slipping. That means the block will be at rest. So block has a tendency to move downward due to the force of mg. So in order to prevent the slipping, there must be one friction force that is acting upward. So F is acting upward. Now who is providing the F? F is provided by the normal. What is normal? Normal is coming due to the pseudo force. Entire board is moving towards right. So because of that, and pseudo force is coming. If I see from the reference frame of the block, I am blocker mathay bose achi. So I am in the non-inertial frame. So for that person who is in the non-inertial frame, he sees a pseudo. The pseudo will be acted opposite. MA is a pseudo, acted opposite. So MA is balanced by N. So N should be equals to MA. What is the limiting value? Limiting of the friction mu times N. So mu into MA. So this is the limiting value of friction. That is the maximum possible value of friction that can be offered by the board on the block. So our requirement of friction is F. F should be equals to mg. Requirement of friction should always be less than or equals to F. Okay. So to prevent the sliding. So mg must be less than mu ma. So indirectly mu should be greater than or equals to g by a. So either it can be greater than g by a or it should be equal to d by a. So both are correct options. So option A and C both are correct. There is a bead of mass m. Bead means small mass. Point mass m is there. Located in a parabolic where with its axis vertical and vertex downward. Equation of the parabola is given as x square equals to a. Coefficient of friction means the highest distance above the x-axis. Above the x-axis means this side. Let us say this is the y. So what is the value of y? For which the block or the bead will be in equilibrium. Equilibrium means it will be at rest. It is not moving. So a point A, let us say it is achieved at point A. If I draw a tangent at point A, let us say this tangent is making angle theta. So basically a bead of block M is there which is resting at a particular point A such that tangent at point A is making angle. So mg sin theta will try to pull the bead downward. Now corresponding to this the friction will be acted upward. Okay, and here it is mg cos theta. Mg cos theta should be in the normal direction. So capital N becomes mg cos theta. Corresponding to that, Fm should be how much? Fm should be mu into n. So mu into n means mu mg cos theta. Mu mg cos theta. This is the limiting value of friction. Now in order to get net force to be zero, when equilibrium যদি থাকতে হয়, that means net force should be at zero, that means at rest. That means mg sin theta should be equals to our F number. So this is the requirement of friction. And requirement of friction is always less or equals to F number. That means what we can say that mg sin theta number should be less or equals to mu mg cos theta. Or tan theta should be less or equals to mu. Okay. So what is tan theta? Tan theta is nothing but the slope at point A. The slope at point A is nothing but dy dx. So dy dx at point A is how much? Dy dx at point A is basically আমাকে দেওয়া রয়েছে that x square equals to ay. So if I differentiate both sides, so 2x times dx should be equals to a into dy, or dy dx is equals to 2x by a. That is our tan theta now. Let's look. So that means dy dx at point A is basically 2x by a, and that should be equals to tan theta, and that should be equals to mu. Okay. So x should be equals to how much? A mu by 2. This is the x position where the bead will be in equilibrium. But you are asked to calculate the y location. So since the point A is lying on the parabola, point A is lying on the parabola. So for parabola, x square equals to ay. So y is how much? X square by a. What is x? X is a mu by 2 whole square by 8. So ultimately mu square a by 4. That is your answer. Option C is the correct. So bead is resting at point A means it should be in equilibrium. That means mg sin theta is pulling the bead downward, and opposite to that the friction is there. So friction is opposing this. So in order to prevent the sliding, again F number should be equals to mg sin theta. F should be equals to mg sin theta. that requirement of friction must be less than or equals to Fm. হ্যাঁ, এই কন্ডিশনটা বারবার আমরা ইউজ করব টু ক্যালকুলেট দ্য লিমিটিং। So Fm is what? Fm is the limiting value of friction, that is equals to mu into n. N is mg cos theta, so mu mg cos theta. সেখান থেকে আমরা পেলাম কি tan theta must be less or equals to mu. That means dy dx at point A should be less or equals to mu. Now how to calculate the dy dx? For that you have to differentiate the equation. The equation of the parabola is given as x square equals to ay. So I differentiate both sides with respect to x and with respect to y on the left hand and right hand. So ultimately what I am getting, dy dx number equals to 2xy, that is equals to tan theta. So এখান থেকে আমরা x বের করলাম. So once I calculate the x, since the point A is lying on the parabola, it will satisfy the equation x square equals to ay. সেখানে আমরা y টাকে বের করে নিলাম। বোঝা গেল? এটা কর। So when you apply a force of 1 Newton, the block remains at rest in the downward direction. When you apply a force of 7 Newton, the block will be again at rest. So you are asked to calculate the mu number. So in both the situation, in the first case, mg sin theta is acting downward. Mg sin theta. So mg sin theta, that is mg by 2, because theta is 30 degrees. So that is mg by 2 is acting downward. And corresponding to that mg cos theta means root 3 mg by 2 is acting perpendicular to the plane. So that number is acting as normal. Okay. So in the first case, when you are applying 1 Newton of force, then the particle is at rest. That means minimum is 1 Newton. That means at this situation, the limiting is acting upward. Fm is acting upward. So for the situation number 1, আমি কি লিখতে পারবো যে mg by 2 plus 1, that should be our limiting value, and that is equals to mu into n. So mu into root 3 mg by 2, the first equation. Okay. So mu into root 3 mg by 2 is the first equation. So when the tendency of movement is down, now you are applying a 7 Newton of force, that is more than 1 Newton. Now the tendency of particle is moving upward. So again mg by 2 is acting down, mg sin theta. Again mg root 3 by 2 is normal component, that is equals to n. But now the 7 Newton is more, so friction is acting in this direction. So for the second situation, mg by 2 plus fm should be equal to 7. Now what is fm? Fm equals to again mu mg, mu into n. আমরা এখানে লিখে দিচ্ছি এরকম করে mg by 2 plus mu into mg root 3 by 2, that number is equal to 7. So this is equation number 1, this is equation number 2. So you have to solve these two equations. হ্যাঁ, এটা লেখার সময় এরকম করে লিখছি, দেখ আমি ইকুয়েশন নাম্বার 1টাকে নিচে লিখছি mg by 2 minus mu mg mu root 3 mg by 2 equals to করে দিলাম কি -1 করে দিলাম। Now since I have to calculate the mu number, মিউটাকে বের করতে হবে। হ্যাঁ, মিউটাকে বের করতে হবে। এখানে আননোন হচ্ছে মিউ আর এন। হ্যাঁ, আমি করলাম কি, আমি দুটোকে অ্যাড করব। অ্যাড করলে কি হবে, ফার্স্ট ইফ ইউ অ্যাড দিস টু নাম্বার, তো অ্যাড করা মানে কি এই মিউ পার্টটা কেটে যাবে। অনলি থিং mg by 2 plus mg by 2 means mg equals to how much? 7 minus 1 means 6. That is mg number is 6. এবার সাবট্রাক্ট করব। So once I subtract, now the mg by 2 will cancels out. So on subtracting, আমি কি পাচ্ছি, mu times যে নাম্বারটা, that is 2 times 2 into mu mg root 3 by 2, that should be equals to 8. Now mg is how much? Mg is 6. So 2 কাটলো, so mu into 6 root 3 equals to 8. Okay, so mu becomes how much? 8 by 6 root 3 means 4 by 3 root 3. That is the answer for me. It will put D option. Okay, so in the first situation, once you apply a force of 1 Newton, the tendency of movement is downward. Particle এই দিকে নামতে যাচ্ছে, downward movement, so friction is acting up. When I apply 7 Newton force, then the particle has a tendency to move upward, so friction is acting downward. So in both the situations, these two 1 Newton, 7 Newtons are the maximum minimum value of force. It gives the hint that now the friction is limiting friction, not the any friction less than limiting value. So here the friction value is equals to Fm. So you can directly move into n লিখছি. Okay. 60 kg body is pushed horizontally with just enough force to start it moving across the floor. আমি এখানে একটা F force দিয়েছি that is sufficient to start the moving. That means without any acceleration. And the same force continues to act after. Initially, in order to start the movement, F should be equals to Fm হতে হবে. Now, what is Fm? Fm is mu s into n number. Now, what is mu s? 0.5 into 60. 0. So, 30. 300. Limiting value of friction is 0.5 into 600. Why 600? Because 60 kg normal mg. So limiting value of friction is 300. So initially you apply a force of 300. So block will move, start to move. Now after that, the force continues to act. Now once the particle starts to move, now the force is acting. The same particle, I am applying a force of 300 Newton. But now the block starts to move. And now the friction is kinetic friction. Ft. Ft is what? 0.4 into n. 0.4 into 600 means 240. Okay, 240 Newton. We're asked to calculate the acceleration. So, what is the net force? Acceleration is equal to 300 minus 240. There is mass is 60. 300 minus 240 by 60 means 60 by 60 means 1 meter per second. Okay. CSC. দেখছি mass of 5 kg block is resting on a rough horizontal surface. Follow the coefficient of 0.5. Force of 50 Newton is applied. Acceleration of the block. So force of 50 Newton. So component along is F cos 37 means 50 into 5 means 40. So upward is 30. F sin 37 means 30 Newton. Mass is given as 50 kg. So 50 Newton is acting downward. So normal is n. So n plus 30 should be equals to 50. N is 20. So limiting value of friction is how much? Mu into n 0.5 into 20 means 10. Okay. So as this 10 is less than 40 Newton, so block will move. Okay. So what is the net force acting on the block? So for this block, so this force is 40 Newton. Opposite to that, the friction is there, that is equal to 10 Newton. So acceleration is how much? 40 minus 10 divided by mass is 5 kg. 30 by 5 means 6 meter per second. 6 meter per second is the acceleration of the block. কেমন করে 3 পেলি বাবা বাস খুব ভালো ভালো ঠিক আছে so block is moving towards right initial under the action of horizontal force F. So if I apply horizontal force F and block is moving, that means on this surface the friction is limiting already applied. Okay. So that means F number must be greater than Fm. Now what is Fm? Fm is mu into mg. So F is greater than mg. Corresponding to that, what is the initial acceleration after acceleration? So at initial position, acceleration is equals to F minus mg by m. So this is the initial acceleration. Let us say this is A1 number. Now I am applying another force P, which is making angle theta with respect to the vertical. So because of that, this is the component P cos theta. This is the component P sin theta. P sin theta. Okay. So now the friction acting, so normal has been changed. What is the normal? Normal is equals to mg plus P cos theta. P sin theta. Okay. So now the friction acting, so normal has been changed. What is the normal? Normal is equals to mg plus P cos theta. P sin theta. P sin theta. Okay. So now the friction acting, so normal has been changed. What is the normal? Normal is equals to mg plus P cos theta. Corresponding to that, Fm is how much? Fm is equals to mu into n, mu mg plus mu p cos theta. Okay, and mu is given as tan theta. Mu is given as tan theta. So tan theta into cos theta means sin theta. So mu mg plus mu means tan theta. Tan theta means p cos theta, p sin theta. And here mg into tan theta plus p sin. This is the number. Okay. This is the normal Fm value. So now in the second situation, what is the net force? Net force is P sin theta plus A. So actually the second situation is how much? P plus A plus P sin theta by minus Fm divided by M. So AF is how much? AF. P is how much? P sin theta. P sin theta minus Fm means minus mg. আমি এই এফএমটা ইউজ করি mg mu times mg minus p sin theta divided by m. So p sin theta means cancels out. So a minus mu mg by m. Okay. Acceleration in the second situation, a plus p sin theta is the horizontal force. Minus limiting, minus friction means minus Fm. Fm means minus mu mg minus p sin theta. So p sin theta is now cancels out করে যাচ্ছে. Ultimately we are left with the same answer A2. So A2 and A1 both are same. A2 and A1 both are same. Acceleration remains same. There is no change in acceleration. On a particular surface, let us say ধর বললাম যে একটা ব্লক রয়েছে whose mass is m is resting. Now in this surface, for this surface mu s and mu k numbers are given. So we apply a force of A which is time varying force that is equal to 2p. Okay. So once we apply a force which is varying with respect to time, so gradually the block will start to move whenever the friction on the surface reaches the limiting value. Okay. So if AF is greater than Fm, then the particle or block will start to move. Block will move. Okay. Now what is Fm? Fm number is basically equals to mu s into mg. That number is equals to F. F মানে 2p. তাহলে at t equals to mu s mg by 2, the particle will start to move. Okay. So if t is less than that, that means 8 times the t naught time. So at t naught time, the particle will start to move. So between 0 to t naught, what is the acceleration? Acceleration is 0. Okay. Between 0 to t naught, the particle is not moving because the applied force is less than the Fm value. So at t naught, the particle will start to move. After that, what happens? So after t naught, when the time is when t is greater than t naught. Now the particle is moving. Why? Because the applied force F is equals to 2p, which is greater than Fm. So now the acceleration will come. But since the particle is moving, so now the friction will be kinetic friction. Means Fk. What is Fk? Fk is mu k into mg. So corresponding acceleration is how much? 2t minus mu k mg by m. Okay. So that means equals to 2 by m into t minus mu k into g. So A versus t diagram represent it is a straight line with a slope of 2 by m. Because আমরা লিখলাম কেমন করে A equals to mx plus c ফর্মে লেখা হয়েছে. So it is a straight line, slope of 2 by m. So gradually the line will increase. But so there is a discontinuity. তার মানে কি এই যে লাইনটা দেখাচ্ছে এইটা হচ্ছে t up to t naught time, এইটা হচ্ছে t naught time. Up to t naught time there is no accident. Just after t naught the friction becomes limited. So there is a discontinuity between the graph. It is not continuous and then it is straight line. the straight line. So this is the correct way of representation of acceleration versus time. This is the answer. Okay. The discontinuity থাকছে why? Because the friction is changed from static to kinetic at time t naught. What is the value of t naught? T naught is mu mg by mu s mg by that is the t naught. At this t naught, the particle starts to move. So whenever the particle starts to move, now the friction has been changed to kinetic friction. So since the friction changed to kinetic friction, so there is a discontinuity in the graph. So option D is the correct. So mass of the insect is given as m. It can move up, down, or any direction. Up, down, the incline. Okay. So if mass is m, so here mg sine 37. So mg into sine 37 acting downward. Okay. So mg sine 37 means 3 mg by 5. And this is the mg cos 37. mg cos 37 means 4 mg by 5. 4 mg by 5. See the tendency of the insect to move upward. Let us say the insect is moving up. Insect is moving upward means friction is acting downward. So what is the limiting value of friction? Limiting value of friction is mu into n. Mu is given as 1. So n is equals to 4 mg by 5. So 4 mg by 5 is the limiting value of friction that can be acting. If the tendency of movement of the insect is upward, so friction is acting downward. So net force acting downward is how much? 3 mg by 5 plus 4 mg by 5. So net force acting downward is 3 mg by 5 plus 4 mg by 5. That means it has an acceleration of how much? 7 mg by 5. Okay. So maximum possible acceleration of the insect can be 14 meter per second square. Why? Because the insect is trying to climb upward. Let us say, ধর বললাম যে ইনসেক্টটা উপর দিকে যেতে চাইছে. Once the insect is trying to climb upward, so friction is acting down. Friction is acting downward. So 3 mg by 5 plus 4 mg by 5 is the net force. F net on insect is 3 mg by 5 plus 4 mg by 5. It is 7 mg by 5. 7 mg by 5 is the net force. So acceleration is how much? A should be equals to 7 mg by 5 by m means 7 g by 5. 7 g by 5 means 70 by 5 means 40 meter per second. That is correct. Minimum to divine maximum. So option A is correct one. Okay. Option A is correct one. Now, since option A is correct one, option B is false. Why? Because it is also written in maximum. Maximum is 40. The insect can move with a constant velocity. Check for it. So in order to move the insect with constant speed, net force should be 0. So net force, how it can be 0? Because 3 mg by 5 is always constant. So can I apply another force of 3 mg by 5? So for constant speed movement, so F should be equal to 3 mg by 5. This is the requirement of friction, and that should be less or equal to Fm. It is true because Fm is 4 mg by 5. So I can apply a friction force which is equal to 3 mg by 5, which is less than or equal to Fm. So the insect can move with constant speed. Now, since insect can move with constant speed, so next question is insect cannot move with a constant velocity. It can. So option A and C is the correct one. Option A and C is the correct. Okay. Limiting friction force on B, Fm on B. Both the blocks are of same mass or different mass. After the block A, I think the fourth is applied on block A as shown where T is the time in second. The force is applied at T equals to 0 when the system was at rest. When the system is at rest. আলাদা ধরে না শুরু থেকে। ওকে, তার বললাম যে mass of block B is, let us say, M2, mass of block A is M1. দেওয়া নেই। So limiting value of friction force on B should be equal to how much? Mu S into M2G. Limiting value of friction on block A should be equal to M1 mu S into M1G. Okay. If applied force, if A is greater than FMA plus FMB, then only the system will move. Party will move. Otherwise, it will not move. Okay. So initially, as the time increases, the force is increased. Initially, the T equals to 0, no force is acting. After some time, the force is there. যত force আসবে, so friction on block B and block A will try to increase. If I draw the free body of block B, so this tension on block B will increase with time. Similarly, on block A, this tension will also increase with respect to time. So on block A, the force is there, that is also increasing with time. So on block B, so for no movement, যখন মুভ করছে না, so in order to balance this T, the friction on block B, A should increase until it reaches the value of Fm. Nah? So friction force on block B will increase as time increases. So it is linear variation. Similarly, so initially the force is more than the T. So the block has a tendency, entire block has a tendency to move in the forward direction, in this direction. So again the friction on block A will be in this direction, A from A. So friction will also try to increase, so in order to prevent the slipping. So both friction on both the block are increasing with respect to time. Okay. So this is correct one. This is correct one. This is correct one. So all the options are correct initially. So up to a certain time the friction will increase. Okay. Up to a certain time the friction will increase. Now, after that, once the limiting value has been reached, then the friction becomes constant. Yeah. Initially, আমরা করছি কি, time respective applied force, external force is going to increase. As the external force is increasing, the friction force on both the blocks are going to increase. So ultimately, one will reach the limiting value, another will reach the limiting value in the other situation. দুটোতে একই টাইমে লিমিটিং রিচ করবে না. Both the blocks are not reaching the limiting at the same situation. Both the blocks are reaching the limiting at different situation. কেন? দুটোর মাস আলাদা রয়েছে. Limiting value of A and limiting value on B are different. So both will not reach the limiting value, but it may be possible that until and unless this is correct, এইটা সবসময় ঠিক কিন্তু block will start to move whenever the applied force is greater than the limiting on both the limiting on both the block. যদি mass M2, if I say mass of M2 is greater than M1, so first limiting will reach on block A, then limiting will reach on M2. তাহলে যার মাসটা বেশি হবে তার লিমিটিংটা পরে রিচ করবে, বাট আফটার সার্টেন পয়েন্ট অফ টাইম দ্য ফ্রিকশন বিকাম কনস্ট্যান্ট। কনস্ট্যান্ট কোথায় কোথায় দেখা যায়? এইখানে কনস্ট্যান্ট দেখাচ্ছি, এইখানে কনস্ট্যান্ট দেখাচ্ছি। অনলি অপশন A and B are discarded. A, B কে বের করে দিলাম। So possible options are C and D. And after that, once the block starts to move, then the friction force has to decrease. Why? Because kinetic friction comes into the picture. Okay. So friction যখন কমে গেল, now we should move into the this part. So only the C option shows that there is a decrease in friction. Option C is the correct one. D টা হবে না. Why? Because it shows that kinetic friction is increased. As mu k is always less than the mu s, so kinetic friction value is always less than the Fn number. So that means after certain time, now the friction will be less than the static one. Okay, less than the static. বোঝা গেছে এক্সপ্লেনেশনটা? Initially, both the frictions are zero. Initially, both the blocks frictions are zero. Gradually, as I am increasing the F number, depending on the mass of which is heavier. So, lower the mass, jar mass choto royeche, so that particular particle will reach the limiting one first. After that, the second particle will reach. Okay. That means throughout this process, the friction is not changing itself. Friction is constant. That means it is not changing with time, it means constant. After some time, now the block will start to move, so friction becomes kinetic. And once the friction becomes kinetic, it is starting to move. So friction is less. So you want to move out the 6 kg block. So if I draw the body of 6 kg block, so if I apply a force on this, so the ground will offer a, so on the ground, let us say normal is N1. On the block, let us say normal is N2. So ground is offering a friction in this direction, F1. And because 6 kg is moving over 2 kg, so 2 kg is offering friction in this direction. So 2 kg is offering the friction on 6 kg in this direction F2. Okay. So what is the limiting value of F1 and F2? So F1 should be equal to 0.42 into N1. And F2 is equal to again 0.42 into N2. What is N2? N2 is 20. And N1 is how much? 60 plus 20 is 80. Okay. So net force F minus F1 plus F2. That is the net force acting. Divided by mass in 6 kg. That should be the acceleration. That should be the acceleration. So you are given that A number is 1.5. So F is F minus F1 plus F2 means 0.42 into 60 plus 80 plus 20. That is equal to 6 into A. A means 1.5. So 6 into 1.5 means 9. So A minus 0.42 into 100 equals to 9. So A becomes 9 plus 42. 9 plus 42 means 51 Newton. So if the applied force is 51 Newton, then the block 6 kg will be pulled out with an acceleration of 1.5 meter per second. Option D. I am pulling the block 6 kg towards right. So ground is offering the friction F1 in this direction, and then the 2 kg is acting the giving the friction in this direction F2. Both the friction will be different because the N1 and N2 numbers will be different. N2 is coming due to 2 kg and N1 is coming due to both 2 kg and 6 kg. Total 80. বুঝতে পেরেছিস? So 40 kg slab rests on a frictionless floor. So এই সারফেসটা স্মুথ দেওয়া রয়েছে. This is a smooth surface. So 40 kg resting on a smooth surface and 10 kg on top of it. 10 kg block is acted upon by a hovering force of 100 Newton, resulting acceleration of 40 kg slab. Okay. So for this system, we have to check whether the 100 Newton is acting for the combined movement or not. So আমি যদি ধরি যে entire block system is moving combinedly, so 40 kg has to move in the forward direction. So on 40 kg, if I ask that limiting value of friction is Fm, that should be how much? 0.6 into 10, 100 means 60 Newton. So maximum acceleration of 40 kg mass will be how much? A for 40 kg will be 60 by 40. That means 6 by 4 means 3 by 2 meter per second square. This is the maximum possible acceleration. And 3 by 2 acceleration means, আমি জানতে চাইছি যে in order to produce a 3 by 2 acceleration, what is the force required? So for the combined movement of 50 kg, if I apply a force of F and I want to get an acceleration of 3 by 2 meter per second square, what is the F number? F should be equal to 3 by 2 into 50 means 75 Newton. 75 Newton. But our force applied is 100 Newton. So now both the blocks will move separately. As 75 is the force that is required to move with combinedly, আমাদেরকে দেওয়া রয়েছে 100 Newton of the force is being applied. So right now আমরা এটা কনক্লুড করতে পারি that means the both 10 kg and 40 kg are moving not combinedly, they are moving separately. So separately move করেছে means what? So on 10 kg, if I apply a force of 100 Newton, so now the friction will be kinetic one because they are moving separately. Fk. What is Fk? Fk is given as 0.4 into 100 means 40. Okay. So acceleration of 10 kg is how much? 10 kg is basically 100 minus 40 by 10 means 60 by 10 means 6 meter per second. So that is the acceleration of 10 kg. And for 40 kg, force of friction will be Fk now. What is that force? 40. So 40 is the force. So acceleration for 40 kg will be how much? 40 by 40. That is 1 meter per second. So 40 kg move with an acceleration of 1 meter per second square, and 60 kg, 10 kg move with an acceleration of 6 meter per second square. Okay. So in this type of problem, first of all, you have to check the applied force is there, and that applied force is capable of producing combined movement or not. এটাকে চেক করতে হবে. Once I check it, then only I can confirm what is the correct expression of the acceleration that we should do. আমরা এখানে করলাম কি, প্রথমে চেক করলাম যে so no force is applied on the 40 kg. So 40 kg can move combinedly with 10 kg with the effect of friction. Now what is the limiting value of friction acting on the 40 kg? So Fm, that is 0.6 into 100. Mu s is given 0.6. So 60 Newton is the limiting value of friction that can act on 40 kg. Corresponding to that, this is the maximum possible acceleration of 40 kg. How much? 3 by 2. Now I want to check if the acceleration is 3 by 2 for the entire system, how much amount of force is required. So আমি দেখলাম যে 50 kg block কে 3 by 2 acceleration move করা যায়, so applied force is 75 Newton. But our force is more than 75, that is 100 Newton. Next is that both the blocks are moved separately. So now we draw the free body for both the blocks. So first we calculate the free body for the 10 kg. So for 10 kg, 100 Newton is acting forward. So friction is now kinetic because they are moving separately. Moving separately means the friction has to be kinetic in nature. So kinetic friction is equal to 40 লেখা রয়েছে. Why? Because 0.4 into 100. So with that 40 Newton kinetic friction, what is the acceleration? 100 minus 40 by 10 means 6 meter per second square. Similarly, same 40 Newton will act on the 40 kg mass also. So now the 40 kg is being pulled by the 40 Newton. So what is the acceleration then? 40 by 40 means 1 meter per second square. Okay, so that is the answer. বোঝা গেছে? So in this situation, there are two persons pulling each other through a massless rope. The rope has no mass, so m equals to 0. So if I say rope has no mass, and in a tug of war, both the person pulling the rope, let us say, if I consider one particular point P on the rope itself, so since the mass of that particular point P is 0, so can I say the net force on point P is 0? Why? Because net force is equal to mass into acceleration, and since it has no mass, so this becomes 0. That means, so this person, if pulls with a force of P, then this person is also pulling the same rope with the P force. Okay, so that the net force at point P should be equal to 0. Now, since the person is offering the tension, so that means there must be one frictional force acting in this direction. So this, let us say this is F1. Similarly, the F2 force is there. Okay. So in order to increase the friction, so in order to increase the tension force, that means in order to win the match, so you have to apply more amount of friction. So a person who is applying more amount of friction on the ground should win the match. Why? Because for the entire system, if I take it as a system, so for the entire system, net force is basically the difference of F1 only. There are two friction forces. Now, friction force is always kind of shear force because it is acting parallel to the ground. And normal is the composite type of force because it is acting perpendicular to the ground. So, the correct option is the one who applies more friction force on the ground. So person who is applying more friction force on the ground, he will win, because more the value of friction means more the value of tension. So higher the value of tension on the road means the person will win. Okay. So correct answer for this question will be option number C then. Now moving on to the next situation. In this situation, there is a block which is resting on the XY plane. The block is resting on the XY plane. Now you are applying a force of 6I plus 8J plus 20K on the block. So that means there is a component of force which is 20 Newton acting up. 20 Newton. There is a component of force which is equal to 6 Newton along x direction. So this is a 6 Newton force. And this is the 8 Newton force acting along the y direction. So these are the constant forces acting on the particle. Now the particle has a mass of 5 kg and is resting on a rough surface with coefficient of friction mu equals to 0.4 given. So that means what I can say that the net weight that is acting downward is equals to how much? 50 Newton. So the surface is offering the normal in this direction. So what is the value of normal? So n plus 20, that should be equal to 50. That means n comes to be 30 Newton. So corresponding to 30 Newton n, so now I can calculate the limiting value of friction, that is Fm, that should be equals to mu into n. That means it is equals to 0.4 into 30 means 12 Newton. So the surface can offer maximum of 12 Newton force as a friction. Now the entire block is pulled with the two types of force. One is along the y direction, another is along the x direction. So resultant of these two force is nothing but a force which is acting in this direction. So this is the F net value. What is the F net value? So F net is nothing but equals to under root of 6 square plus 8 square. That is 10 Newton. So applied force is 10 Newton, which is less than the Fm value. That means the block will not move. Okay. So if the applied force is less than the limiting value of friction, then the block will not move. So first option is given that the block starts slipping over the surface. It is incorrect. It cannot slip. It will not move. So since the particle is not moving, now the friction force will be opposite to this net force, but of magnitude 10 Newton. So that means it implies friction acting on the surface is equals to again 10 Newton. Okay. So friction is acting in this direction, which is again the 10 Newton. So this F is the 10 Newton force. This 10 Newton has two components. One is 8 along this y direction, another 6 along this x direction. If I take this angle is alpha, so tan of alpha can be written as equals to 6 by 8, that means 3 by 4, that means alpha equals to 37. Okay, so alpha is 37 degree. So friction force on the cube by the surface is 10 Newton, that is the correct option. Now the friction force acts in the xy plane. Yes, it is acting in the xy plane. Now what is the angle made by the positive x-axis? So positive x-axis is this side, so I have to make the count of this angle. So this angle is how much? Alpha plus 90 degree. So angle should be 127 degree. Why? Because 127 degree is nothing but 90 plus 37. Okay. So that means this answer is also correct and it is in the clockwise direction from the x-axis. Now contact force. Regarding the contact force, what is the contact force? One contact force is friction, another is the normal. So we get the result of friction is equals to 10 Newton and normal equals to how much? Normal equals to 30 Newton. So resultant of these two force should be equals to R contact force, that should be equal to under root of 30 square plus 10 square. So it means root of 1000. That means 10. I mean that is also correct. So both B, C, D options are correct. Okay. So in this situation you have to be very careful regarding the force direction. So since it is a 3D force system and y-axis is not the vertical axis. Here the vertical axis is the z-axis. So weight is acting along the vertical z direction downward. Okay. So correspondingly 20 is coming to affect the normal force. And accordingly once we calculate the normal, then I can calculate the limiting value. And based on that I can comment that the block will not move. Okay. Okay. Then moving on to the next situation. Here there is a system of blocks. So one block of mass 2m, another block of mass n, and only the friction is there on the lower part of the surface where the 2m is resting on the ground. Now it has been given that there is no friction is acting between both the blocks. That means between m and 2m at this surface. In this surface there is no friction force is acting. Okay. Now you are asked to calculate the value of mu for that the system will remain in equilibrium. The entire system will be in equilibrium. That means all the masses are in rest. So there is no acceleration basically. So if the no acceleration is there, so what we can say, this tension force is nothing but equals to mg balancing. Okay. So tension is balancing the mg force. Now for the 2m mass, if I draw the free body of the 2m mass, so for the 2m mass, so let us say this is a 2m particle. Now 2m particle is pulled by this pulley with a tension of T. Another tension is T acting downward. Okay. And there is another tension acting T in this direction. Okay. So total 2T is the force applied on the 2m to produce the displacement. Now since 2T is not able to disturb the particle, that means 2T should balance the friction force. So requirement of friction F equals to 2T, and that should be less than or equals to our Fm number. Okay. Now regarding the Fm, I have to calculate the normal. So this is the normal force acting. So normal is acting upward. So T and 2mg. So here the 2mg force is acting downward. Okay. So N should be equals to how much? N should be equals to 2mg plus T. And now what is T? T is always equals to mg number. Okay. So I am getting T N equals to 3 times of mg. Okay. So normal force acting on the 2m block is 3mg. So now I can write the expression of small f. So small f equals to 2t means 2t means 2 times of mg. That should be less or equals to fm means mu times m. Mu into n means 3mg. Okay. So limiting value should be equals to, so can I write mu equals to 2 by 3. Okay, so mg will cancel out. So mu should be equals to 2 by 3. So this is the limiting value of mu that is required to prevent the block to move. That means the entire system should be in equilibrium. So 2 by 3 will be your correct option. Okay. Now, so in this system, what happens? There are 3 blocks. One of 30 kg, another is 50 kg, and is 40 kg. So both are supported on an inclined plane of angle of inclination 37 degree, and the different values of mu's are also given. Different values of mu's are given. So the upper block, there is a 30 kg block, is prevented from moving by a wire which is attaching it to the fixed support. So there is a fixed support. On that support, I am attached to a one wire which is preventing the 30 kg to slide down. Okay. Now the 3 blocks are in kg, masses are in kg, coefficients are all given, is written. Now you are asked to calculate the maximum value of P may have before slipping take place in it. That means until and unless there is no slipping between these two, all the surfaces in contact, you are asked to calculate the what is the maximum value of P that can be possible for this particular type of situation. Okay. So since this is a 3 block problem, so you have to do it very carefully regarding the calculation part, because every time the component of weight is one is acting downward and another is acting normal to the plane. Okay. So let us say the G which is equals to T 10 acting downward. So component of G along this direction is G sine 37. So G sine 37, that is 6. Similarly, G cos 37, that is equals to 8. So these are the two components of G, that is equals to 8, acting normal to the plane and perpendicular to the plane. Now let us do the problem in this way. Let us say there are the 3 different surfaces. This is the one surface, the second surface, the third surface. So on this surface, let us say N1 is acting. On this surface, 50 kg surface, N2 is acting. On this 3 surface, third surface, N3 is acting. So there are different normal forces acting on the 3 different contact surfaces. Okay. Now let us check the equilibrium of the 30 Newton, 30 kg first. So for the upper block, there is 30 kg. Let us say this is a 30 kg block. For this 30 kg block, so along the component of force should be 30 into 6. Okay. Why? Because 6 is the component of G along the normal, along the parallel direction. So for this situation, for the 30 kg block, so 30 into 6 means 180 is the force acting down. Now, since 30 kg is resting over 50 kg, so once I apply a force of P Newton on the block 50 kg, so 50 kg has a tendency to move downward. So 30 will offer a friction on 50 kg in this direction. Similarly, on 30 kg, the friction will be in the same direction. Okay. So here I am saying applying the friction force is equals to F1 on the surface 1. Okay. Now, so what is the limiting value of F1? So if I apply the limiting friction at point 1, like the contact, so N1 should be how much? N1 is nothing but 30 into 8. 30 into 8. 30 into 8 means 240. So corresponding is 240. What is the normal? What is the friction value? Limiting value of friction is equal to 0.3 into 240. That means 72. Okay, so this number is 72. So if limiting friction is acting on 30 kg, that is offering a friction force of 72 Newton. Now what I assume that it is the same friction that is acting on the 50 kg block also. For the 50 kg, this friction 72 is acting in this direction. F1 is acting 72 in this direction. Now I am pulling this 50 kg with the force of P, and along with that I have also the force of 50 along the plane component. So 50 into 6 into 10 means 50 into 6 means 300. So 300 is the component of weight which is acting in this direction. Now let us say both 50 and 40 are moving combined. Both 50 and 40 kg blocks are moving combined. So for that, I am saying that here the friction is F. Okay. So this is the free body of the 50 kg. Similarly, once I am saying both the blocks are moving in a combined way, so correspondingly, I also show the 40 kg also. So corresponding the component of weight along this is 40 into 6 means 240. 240. Now this friction which is acting on the 50 kg come in the direction from 40 kg. And along with that there is another friction force that is acting on this particular surface. On this surface is, let us say this is F3. Now what is F3? F3 is again I am applying the limiting value of friction. So F3 is how much? F3 is basically equals to 0.5 into N3. Now what is N3? N3 is total mass, that is 30 plus 40 means 70 plus 15 is 120. So 120 into 8. 120 into 8. So N3 is equals to 0.5 into 120 into 8. That is the N3 number. Okay. So 960 into 0.5. That means 480. 480 is the limiting friction acting on the 40 kg block. Okay. Now, if I say both the blocks are moving in a combined situation, so these two blocks are moving in a combined manner, so can I balance the force? So for this system, what is happening? So if I say these are moving in a combined way, so total mass of the block is how much? 40 plus 15, 90 kg. So corresponding one force is 300. Another force is P over here. Another force is how much? 240. These are the three different forces acting on the 90 kg block, and upward force is here the surface friction is offering 72, and here the friction is 480. Okay. So for this situation, what I can write, 300 plus P plus 240, this number should be equals to 72 plus 480. Assuming that both the blocks are moving combined. Okay. So 240 plus 480 means ultimately I am getting 72 plus 240. So this 240 cancels out. Okay. So P plus 300 equals to this number. So minus means how much? P becomes 12 Newton. P becomes 12 Newton. So I have to check whether I am getting the correct answer now. So for checking, you have to check whether the friction that I have assumed on the surface of 50 kg and 40 kg, that 8 number is coming to be less than the limiting value or not. Okay. So let us do it in any other situation. So if I say for the equilibrium of the 40 kg, so for 40 kg, what I write? So 240 plus F number should be equal to 48. Okay. So that means F should be equal to 240 Newton. So I have to check whether that F number is less than or equals to FM1. Now what is the FM number? FM is for F component. F means the correspondingly 0.4 mu is 0.4 into n2 number. N2 number. Now what is n2? So for that n2, if I calculate over here, so n2, so this is for a checking purpose. I am now checking whether both the blocks are moving combinedly or not. That means I have to check it with the friction. So what is n2? n2 number is basically the normal force coming on the 50 kg surface. That means 50 plus 30 means 80. So 80 into 8, 640. n2 becomes 640 Newton. 640 Newton. So corresponding to that, Fm should be how much? 0.4 into 640. 0.4 into 640. So 0.4 into 640 means how much? 0.4 into 640 means 64 into 4. 64 into 4. So it was a 16, 256. Okay. So 256 is the limiting value of friction. I got the requirement of friction is 240 Newton. So that means I am getting the correct result. Okay. So that means whatever I have assumed, that means all the blocks are moving combined. That is correct. Okay. So for that situation, requirement of P is how much? Requirement of P is 12 Newton. So 12 will be your answer. Okay. So this type of problem had to be dealt with very much carefully. Why? Because there are so many component of forces are coming, so you have to take it carefully and you have to do it in a thorough way. Okay. Just pause the video and watch it once again. Try to redo it. Okay. So that means you will understand if you do it by your. So pause the video and try to solve it once more. Now moving on to the next situation. Now here there are two blocks. Here there are two blocks. Bigger block, capital M is there, small m is there. Now they are arranged as shown in the figure. So there is friction is everywhere. mu1 is there, mu2 is there. And you are asked to calculate the acceleration of the block A. So this is a constant motion problem where, let us say I am saying the block small n is moving downward with an acceleration of A. Okay. And in that process, the capital M is moving with an acceleration, let us say A naught in this direction. Okay. So if I write the constant relation first, so keeping the string like this way, so 1, 2, 3, 4, 5, 6, 7 and 8. So these are the 8 important points on the string itself. So I am writing the constant relation. So point 1 is moving leftward, rightward. So it will reduce the length of the string. So minus A naught. Then 2 and 3 are fixed fully. So all 0, 4, 5 is also 0, 6 is moving towards right. So it is again minus A naught. Now 7 is moving in this direction, but the string is vertical. So 7 has no importance on the increasing or decreasing of the length of the string. Now 8 is moving downward. So it will increase this. So plus A should be equals to 0. So I am getting the constant relation that A should be equals to 2 times of A. A equals to 2 times of A. So particle M has two accelerations. One is with respect to capital M, it is moving down, and with respect to ground also it has another acceleration A naught right. So that means I have to make the concept of pseudo force. So with respect to, so as an observer, if I standing on capital M, so I am standing on a frame which is moving, accelerating with A naught acceleration. That means it is the non-inertial frame of reference. So for that frame, the small m has the pseudo force. So if I draw the free body of the small m, so one tension is T acting over here. So one force is mg is acting downward, and because of this, the particle moving with an acceleration A in this direction. Okay. And with respect to capital M, it has an acceleration A naught rightward. So because of that, the pseudo force will come in this direction. So I am writing the pseudo force on small m is A into A naught. And the surface is offering a normal reaction in this direction. Okay, let us say this is the N1 number, N1. And because of this, there is a tendency of the block to move in the downward direction, let us say. So that means in that situation, the friction is acting in this direction, that is F1. Okay, so this is the free body of the M. So if I write, so net force along acceleration is how much? mg minus T minus F1, that should be equals to M into A. This is the first equation. Second equation I can write along the y direction or along the horizontal direction, that means n1 should be equals to m into n. n1 should be equals to m into n. And what is the friction force? Friction force is basically in this equation what I can write, the friction force F1 equals to mu1 into n1, because they are moving, so kinetic friction is acting, so mu1 into n. Okay, so now come to the free body of the capital M. So for the free body of the capital M, so capital M is resting on the ground, and yeah, let us say on this surface the normal force acting is N2. Now N1 acting, so N1 is acting on this surface by capital M. So on capital M should be N1 in this direction. Now once I am trying to draw the free body, so I have to separate the pulley. So here the T will be there, here another component of T will be there, now here will be another T will be there. Okay, and entire block capital M is moving towards right with an acceleration of A0. Okay, so again I have to write the two different equations for the capital M. One, if I draw the vertical force balance, so mg, capital MG is acting downward, so for N2 upward, N2 should balance mg and T. So third equation is N2 should be equals to mg plus T. Okay, N2 is upward, mg downward, T is downward. Now net horizontal force acting on the block is 2T minus N. The fourth equation is 2T minus N1 should be equals to capital A into A0. Okay, so these are the four equations, and along with that the fifth equation is the constant equation. Along with the fifth equation is the constant equation. Now, entire situation is that the friction is acting in this direction. So here the friction will be there. That should be equals to F2. So 2T minus N1 minus F2 should be equals to M into A0. And what is F2? F2 should be equals to basically mu2 into N. Okay. So now I have to identify how many unknowns are there and what are the number of equations that I am getting. So first unknown is a T, then A, then A0. Okay. And then N1, one N1 and another is N2. Okay. So these are the unknowns. So how many unknowns? 3 and 2, 5. So how many equations are you getting? Also 5. So using these 5 equations, you have to solve the 5 unknowns to get the result. So in this question, you are asked to calculate the acceleration of the block M. So capital M acceleration, answer will be our A0. Okay. So these several questions are to be dealt again very carefully, because you have to do the free body diagram very carefully. So ultimately, once I do the free body diagram and then identify all the different forces acting on the block, then only I can write the equations properly. And once I write the equations properly, then only I can get the answers. Okay. So again, you pause the video and try to look the situation very carefully and write all the equations by your own. Then only you can get the understanding. Okay. Thank you then.